Welcome back, everyone. In this video, we're going to use the tool Bandit to review a Python application to find security vulnerabilities. Bandit is a static analysis tool, and it can find issues like SQL injection, hard-coded passwords, cryptography issues, and point out good security practices in your code. I'm in Windows 11. I already have Python installed. If you need help with this, check out my video linked here. Let's start by creating a directory called Bandit, and we'll cd into that. I'm going to create a virtual environment to manage my dependencies separately from my global Python installation. This isn't strictly necessary, but I think it's good practice. Let's execute the command python-m venv, and I'll give my environment a name of myenv. It takes a moment to run. Let's run dir, and we can see a directory called myenv was created where all my virtual environment setup is located. Now let's activate the environment we just created by running myenv script activate. This script will adjust my environment variables so Python commands refer to the versions in my virtual environment rather than the global installation. Notice the prompt is changed to indicate the virtual environment is now active. Now let's install Bandit. To do that, we'll run pip install bandit. Pip, which is Python's package manager, downloads and installs Bandit and all its dependencies. If we run bandit-h and scroll up a bit, we can see all the out-of-the-box tests that Bandit will run. These tests will allow it to identify vulnerabilities in our code. Scrolling up a bit more, you can see the tool has a bunch of options that you can turn on. We'll look at a few of them when we scan our project. Okay, now we need something to scan. Let's go out to GitHub and download a project. Let's type in github.com/contrast-security-oss. Here's a list of all the Contrast projects. The project we're interested in is called Django. Let's scroll down. Django is a purposely vulnerable application similar to the Java application WebGoat. It contains a lot of vulnerabilities on purpose and will be a great application to test Bandit with. We don't need to worry about installing or running the application. Since we're doing a static application security test, or SAST, we can simply download the source code and run Bandit on the code. Let's open up the code dropdown and copy the location of the repo. We'll close out of the browser, and back in our command window, let's type git clone and paste in the URL we just copied. It takes just a moment to fetch the code. Let's run the tree command on the directory to see what we got. Scrolling back up through the code, we can see there are HTML files, CSS files, Python code of course, Markdown, and some build scripts. Alright, let's run Bandit. We'll type in bandit-r and the directory where our code was cloned. The -r option does a recursive search through all the directories, and it very quickly assesses our code. We get a nice summary at the end of the output. 5,159 lines of code were scanned. In the output, it divides the results into issues by severity and confidence, and there's a low, medium, and high of each. So a high severity, high confidence issue would be the most important findings to pay attention to first. Scrolling up through the list, we see a possible SQL injection issue called out as medium severity and low confidence. It gives us the location in the code where it was found, along with the code snippet. Below that are two possible hard-coded passwords. The code snippets shown would seem to indicate these are legitimate issues. Now let's run the command again, but this time let's capture the output in a file so we can save it. Let's recall the command and add some additional command line options. First is -f followed by CSV. This will produce output in a comma-separated list of values like a spreadsheet. And we'll add -o to save the output, and our file will be called bandit.csv. And we see our file was written to bandit.csv. Let's look at the CSV file with VS Code. We'll run code space bandit.csv. I have a VS Code plugin that makes viewing CSVs a bit easier. Along the top are the column identifiers. We can see the file, type of test, the severity, confidence, and other information are all captured for each issue. Scrolling through the list, we can see some of the issues were found in application code, while other issues were found in test code. In general, Bandit did a good job of identifying issues. Let's exit out of VS Code. Let's look at how we can use Bandit in a pipeline build to exit based on the return code. Let's use Notepad to create a file called build.bat. This will be a very simple file, nothing complex, just illustrating how the tool could be added to your CiCd build. First, let's turn echo off. We'll run the bandit command as we've done already. If no issues are found in the code, Bandit will return 0. Otherwise, it will return a non-zero value. We'll add a conditional using error level. Error level is a system variable that stores the exit code of the last command executed. If error level, which captures the return code from Bandit, is not equal to 0, then we execute a block of code. First, we'll print a message saying the security issues were found, and to actually terminate the script, we'll use the exit command. The command exit/b error level is a command prompt script that exits the current batch script or command function and returns the value error level to the calling process. Now let's save that batch file and let's run it. At the bottom of the output, we see the message stating that we got security issues, and exit terminates our script. Of course, the script would have terminated anyway, but in the context of a large build script, you could easily break the build when security issues are found in your project. Alright, that's it for this time. Thanks for watching, and remember to always begin secure.